Good evening, everyone. My name is Sahil Singh. I am from Data Science Branch, VIT Chennai. My registration number is 24BDS 1066, and this is a topic of computer networks, which I will be explaining, which course code is BCSC 308L, and the topic which I will be explaining is switching in communication networks. So let's see what are the important things in it. So first we will see what is the origin, why does it matter, and evolution of switching over time. But first, let's focus on what does actually switching mean. Switching is the process of directing data from a resource to a destination across a network using intermediate device such as routers and switches. It decides how information flows through the network and why it was needed. In early communication system, connecting every device directly to each other is not feasible and not practical in the sense for obvious reasons. Switching solves this by allowing shared use of communication line, improving efficiency for the networks, and it was easily flexible and scalable. So that's how we got to the point of switching. So there were many types of switching mechanism, but the prominent ones are message switching, which evolved after to circuit switching, and then we get to the modern era where we use packet switching. The origin of it was telephone networks pioneered circuit switching in the late 19th century as computing grew. Packet-based methods emerged to handle bursty and data-centric traffic, and nowadays also in the modern era we use this packet switching, which once started from the message switching. So let's see what's more in this. Types of switching. The three major types of switching, as we saw, circuit switching, packet switching, and message switching. This was the first the first thing that was made and accepted by a lot of people. In it, there's entire message are stored and forwarded immediately. Its pros are, can I say, it is more efficient than circuit switching because the links are only used when the data is actually moving. But its drawback is it's very slow for modern needs since the node must store the entire message before forwarding it. Large files can cause massive delays and require a huge storage at every stop. So, because the actual definition, if I want to explain it with an analogy, I will explain it like let's see if I have in the future in the slides. So, okay, no. So I'll explain it here only. So for message switching, think of it like sending a physical letter through the post office. Message switching does not require a dedicated path. Instead, the entire data, the message is sent as one complete unit and from one node to the next. How it works, it uses a store and forward method. An intermediate node like a router receives the entire message and stores it, wait for the next link to be free, and then send it to forward. And now for the circuit switching, which came after the message switching, in circuit switching, a dedicated communication path is established between sender and the receiver before the data transfer actually occur. This path stays open and exclusive to those two user until the connection is terminated. How it basically works, think of it as a traditional landline telephone call that we used to have in earlier days. When you dial a number, the network plugs in a series of switches to create a continuous wire-like connection just for you. It guarantees bandwidth and no delay once connected, but its drawback is it is inefficient because it doesn't allow other user to access that line until you are free. So let's say if you are talking to someone and after some time you stop talking, the network pathway will still be there until it's terminated, and no one else is will be able to use it. And lastly, for the packet switching part, the data is broken into packet and each routed independently. The analogy I will give for this is sending a book by mailing each page in a separate envelope. This is the foundation that we use in modern internet. Instead of sending the whole message at once, the data is first broken into small chunks called packets. Packet switching, packet and then sent over. How it works basically is each packet contains a small piece of data plus a header, the destination address. Think of it as a pointer thing where we have data and a memory address which is jumps to. Packets can take different route to reach the destination. It doesn't need a specific direction like we use in circuit switching. Once they arrive, Once they arrive, the receiving computer reassembles them into the original file. The pros of it is extremely efficient and resilient. If one path is blocked or broken, it still manages to get to the user because it can take multiple pathways. But the con is packets can arrive out of order. It doesn't. Some packets can, like suppose we send a packet in a format of 1, 2, 3, 4, but user can accept it as 3, 1, 2, 4. So that is a con, which we can overcome. We will see it in the later videos. For let's move forward and dig deep into the circuit switching. I already gave you the analogy for this. Is imagine you are making a phone call. This is a different one. When you dial the system, when you dial, the system set up a dedicated line which is between you and your friend. That line stays reserved for your conversation only, and no one else can use it until you hang up your phone. And this sounds very promising, but it's like reserving a private lane on a highway. Once you enter it, no other cars can use that lane until you leave it. Even if you're not driving at full speed, no one else can use that path. It will give you a feeling of a president, but this is how it is. It is a benefit to have this system, but it is not the most efficient one. Let's see the more technical definition of a circuit switching is. In a switch network, it consists of a set of switches connected by physical link. A connection between two stations is a dedicated path made of one or more links. What does that mean? It works and operates over the physical layer, which is one of the part of 7 layers in the OSI model. Let's see further. So here the heading is missing, but I can still tell you. The circuit switching operates basically on the physical layer, which I said earlier. Physical layer means wire fibers. Why, you ask? Once a circuit is established, the physical path is reserved end to end. It implies like unlike packet switching, which works on the network layer of the OSI model. Circuit switching doesn't deal with the logical addressing part of the data during the data transfer, and it is purely about reserving and using the physical resources that are available to the system and the network. So this is the basic networking diagram for the circuit switching. You can see one side there are three terminals. There can be many more, and other side also three terminals. This is how we set up the circuit switching. In between, you can see different switches or router, which will establish a path between one system to other, which will be again you know that it will be a private path and no else once let's suppose this is device 1 and this is device 6. So once the pathway is formed between device 1 and 6, No other computer or terminal can access that pathway. So, what are the three phases of establishing the circuit switching? First is the setup phase, second is the data transfer phase, and the what is data transfer phase, and the last one is the teardown phase. So, let's see each of them one by one. The setup phase. The purpose of the setup phase is to establish a dedicated path between sender and receiver before any data is sent. The process for this is the source sends a connection request, like it is like dialing a phone number. The switches along the path allocate resources, frequency band in FDM, or and time slot in TDM, which is now then end-to-end addressing, like telephone number or global ID is used to identify the destination. Once the destination accepts, the circuit is established. Think of it like booking a train ticket before you travel. We reserve our spot before even the journey begins. So now let's see the second phase, data transfer phase. Purpose, actual communication happens over the reserve circuit. So the pathway that we form, now it's time to send the data over. How does the process begin? Data flow as a continuous stream of signal, not packetized in the packet networking. Since the path is dedicated, there's no addressing overhead during transfer. So in packet switching, we know that we need a pointer like approach. The next address should be known. But since in data switching, it there's only a single path, so we don't need that addressing overhead here. The circuit guarantees a bandwidth and low latency. Even during silence, like pause in a phone call, the circuit remains reserved. This is the only drawback of the circuit switching because it requires a lot of storage in that regard because you have to wait. Others are waiting for you to be over. Analogy, again, driving a private lane, once we are on it, no one else can use it until you're done. Tear down phase. Once all the data is transferred from one point to the other, now the everything is done. So we have to free up that connection so the others can also enter it, and it will repeat the same sequence again and again in the circuit switching. So the process is either party, caller or receiver, send, sends a signal to the end to end the session, like hanging up the phone. Once that happens, switches free up the reserve frequency band or time slot, TDM and FDM. The circuit is dismantled, making resource available for the new connection. And it is again one at a time. It's not like there are several will be allowed again. It will again form a connection from second terminal to the other level. Sorry for that analogy. Returning your re- reserve ticket seat after the journey so others can use it. Summary in the circuit switching, we can summarize it as setup, resource, and establish a path, data transfer, continuous flow of signal over dedicated circuit, and tear down phase, which releases the resource after the communication and has done. And this is all about circuit switching. So in this video, I will be keeping it till there. And for the next video, I will cover the packet switching one. And message switching one is not really that important. It was one of the first thing, and the concept that I explained earlier, that whole message is sent one at a time. At each node, all the message is sent, and it won't get forward until the node receives the whole message. So it takes a lot of storage and it is inefficient, which is why we shift from message switching to circuit switching. And in modern times, we use packet switching, which I will cover in the next video. If you have any doubts regarding this topic, you can ask me in the comment section. Thank you for watching. Uh,